Hi friends, welcome to Unacademy, India's largest learning and teaching platform. I hope students are audible. Unacademy offers plus courses for Karnataka CET students. Students who want to write CET exam in the year 2021, you can subscribe the plus courses of Unacademy. Whenever you subscribe an Unacademy, you are given student both class 11 and class 12 topics that will be done in detail. You will be given, daily practice paper, full length mock test with analysis. There will be also quizzes. So students, in case if you are, wanting to excel in CT exam, you can subscribe. But whenever you subscribe, kindly make use of this is the code you are going to use it, and see to it that you will be joining the batches, because a single subscription unlimited access today. You have a comprehensive batch and you have a Kannada batch, so whichever you feel appropriate you can join. We have a 12 months plan starting at the rate of you know starting at the rate of 12,375. We have a 6-month plan at the rate of 10,125. So in case if you are interested, see to it that you will be joining any one of these batches. Make use of the code Bhavani Live and get the discount. There is a champions batch also. We have different combinations like PCM. So you have to enroll your name for and this has already started from 15th of October. In case if you are interested, kindly enroll your name for this champions batch also. Your test for Karnataka CET, kindly enroll your name and see to it that you are cracking, the CET with a good ranking. Students, before you go for a practice test, make sure that studied a particular topic, because only after studying you should be writing the test. Otherwise, it becomes, simply a guessing work. So you should know it, you should understand it, and then you should go with the questions. So today I will be, starting with mock tests on chemical equilibrium. So today's mock test is for chemical equilibrium, class 11 topic. So we'll try to take the first question. Following solutions were prepared by mixing different volumes of sodium hydroxide and HCl at different concentration. So students, here, as you can see, HCl and NaOH is mixed with different volume. You can see 60, 40, 55, 45, like that. And you have to find out in which mixing the pH will be equal to 1. Since the question is asked about pH and they are expecting that the pH value should be equal to 1. That means they are expecting that the concentration of H plus ion should be 10 to the power of minus 1, isn't it, student? Because only if it is 10 to the power of minus 1, then you will get pH as minus log of H plus. H plus is how much? 10 to the power of minus 1. So minus minus plus 1 log 10, that is nothing but 1. Now whenever an acid and a base is mixed, we use the formula for an acid-base mixture. The formula is V1N1 is equal to V1N1 minus V1N1 minus V2N2, that is equal to V3N3. So this will be the formula for students. This will be the formula for acid-base mixture. Now since it is HCl and sodium hydroxide, normality is equal to molarity also. So if I am writing molarity M1 in the first case, if I am finding out the concentration of H plus, then V1 N1. V1 is 60, N1 that is M1 is 1 by 10. This one. Minus 40 into 1 by 10. 40 into 1 by 10. And divide by V3. What is V3? V1 plus V2. And V1 is 60, V2 is 40 student. Therefore, totally it will be how much? 100. So, this whole thing divide by 100. So, if you are calculating here, this will be 6 times and this will be 4 times. 6 minus 4, that is 2. Right? So, you are going to get 2 and into, okay, into, 10 to the power of how much? You are getting minus 2. Okay. So whatever it is, you are not getting 10 to the power of minus 1. So we need not go for so much detail. We need to get H plus concentration as 10 to the power of minus 1. We will check for the second one now. Let me take it as M2. So H plus 55 ml, volume is 55 and its normality as 1 by 10 minus 45 into 1 by 10 and this divided by 100 because 55 plus 45. Now this 5 11s are, 5 2s are, 5 9s are and you have 5 2s are. Correct? So 9, 10, 11. Correct? That means you are getting here 2 by 4. So this will be 2 by 4. Okay. So into 100. Right, student? That means how much you are going to get? So this will be, so you can see here, this is 9, 10, 11. Correct? No. This will be 2 by 2. 9, 10, 11, that means 2, right? Okay, so this will be 1 by 100 we are going to get. That means you are going to get 10 to the power of minus 2, not 10 to the power of minus 1. We can't go with this. We will try third one. M3 is equal to, H plus is equal to 75 into 1 by 5 minus 25 into 1 by 5 divided by 100. This is 5 ones are 25, 5 5s are. This is 5 ones are, this is 5 5s are. So 15 minus 5, that will be 10 student. So you are going to get 0.1 or 10 to the power of minus 1 as the concentration. And we said when 10 to the power of minus 1, pH will be equal to 1. So this is the answer. Under which option you have C? Under D. So answer will be D because D has given the answer C. Understood? So first question answer is actually C, student. That is, here it is D, but in the answer option D has given C. Okay. So we will go to the second question. The solubility of barium sulfate in water is 2.42 into 10 to the power of minus 3 gram per liter at 298 Kelvin. The value of its solubility product will be. Now look at this problem, student. Solubility of barium sulfate is given and S is given and KSP is asked. What is solubility product? KSP. Now the question is asked for barium sulfate. We know that barium sulfate ionizes as Ba2 plus and SO4 2 minus. Okay, Ba2 plus and SO4 2 minus. Now, when I say Ba2 plus SO4 2 minus, let me assume that the solubility as S. Okay, so you know KSP is equal to, that is solubility product is equal to molar concentration of Ba2 plus into molar concentration of SO4 2 minus. So KSP is equal to S into S, that is nothing but S square. Question is asked about solubility product. So you need to know what is S now. Here the solubility is given, student. S is given, but the S is given in gram per liter. S should be given in mole per liter, isn't it? Because we assume in terms of mole. Therefore, the solubility in terms of mole will be, if you want to calculate the solubility of barium sulfate in terms of mole, then it is 2.42 into 10 to the power of minus 3 mass by molar mass. What is the molar mass? 233. Okay. Now when you calculate, how much you will get? See, 2.4 to 233. Correct? That means 0. You will get 0.1, something like that. That means you will get the answer here as 1.04. Let me convert this into 10 to the power of minus 5. So, mole liter. Mole per liter. So, KSP is equal to 1.04 into 10 to the power of minus 5 square. So, that will be 1.08 into 10 to the power of minus 10. Mole square and liter minus 2. So the answer will be, student, option A, 1.08 into 10 to the power of minus 10 mole square per liter square. That is, option A will be the right answer. So I hope you are understanding. We'll go to the next one. Which one of the following conditions will favor maximum formation of the product in the reaction? So you have to find out under which condition the amount of X2 produced is highest. So let us try to find out, when such kind of question is asked, how to go with the answer. Now you have to understand the Le Chatelier's principle. In this reaction, product formation means it is associated with release of energy. During X2 is formed, energy is released, given out. It is an exothermic reaction. Therefore, if you keep the temperature low, student, the system wants to increase this temperature. When we keep the temperature low, at low temperature, the system wants to increase the temperature. How the system wants to increase the temperature? If you decrease the temperature, the equilibrium is disturbed and the reaction wants to re-establish the equilibrium. So, if the temperature is lowered, now that lower temperature effect is nullified by increasing the temperature. On which direction the temperature increases? Forward direction. If it is forward direction, you know more and more products are formed. So for temperature, the condition will be low temperature. Okay. Now let us see how do we predict, pressure. If you look at this reaction, whether it is reactant or product, all are gaseous in nature. That means, student, if that is the case, look here, 1 mole of A2 and 1 mole of B2 is reacting. So number of moles of reacting are, number of moles of reacting are 2 moles. And the number of moles of product formed is 1 mole. So student, 2 moles of a reactant react and 1 mole of a product is formed. Keep in mind. So during the forward reaction, there is a decrease in number of gaseous moles. From 2 mole, it has decreased to 1 mole. That means forward reaction is decrease in pressure. So suppose if you increase the pressure, then the system tries to decrease that pressure. If you increase the pressure, the system tries to decrease the pressure and the equilibrium is re-established. So on which direction there is a decrease in pressure? That's a forward reaction. Therefore, students, low temperature and high pressure will favor maximum formation of the product. In general, remember student, if at all the reaction is exothermic, the low temperature will favor the reaction. If it is endothermic, high temperature favors the reaction. If the forward reaction is decrease in number of moles, then increase in pressure. If it is increase in number of moles, then decrease in pressure. Okay. So answer will be option A. So go to the next one. The equilibrium constant of the following are. You can see there are 3 reactions given. All the 3 reactions are at equilibrium. So you have to write, okay, using these equations, the equilibrium constant for a new reaction. Now consider now N2 plus 3H2 giving 2NH3. The equilibrium constant for this reaction is K1. N2 plus O2 giving 2NO. Equilibrium constant of the reaction is K2. H2 plus half O2 giving water, it is taken as K3. Now we have to write the equilibrium constant of the reaction 2NH3 plus 5O2 giving 2NO plus 3H2. So you have to write the equilibrium constant for this reaction. We are writing equilibrium constant for this reaction. So what do we do now? So if you can see here, in this reaction, this is formation of ammonia. But here, ammonia is the reactant. Here the ammonia is the product. So in order to get this reaction, equation 1 need to be reversed. When we reverse the equation 1, the equilibrium constant will be, student, it is reverse means backward reaction. It is a reciprocal of this equilibrium constant. If K1 is the equilibrium constant for the forward reaction, 1 by K1 is the equilibrium constant for the backward reaction. And so 1 by K1 it changes. Now look at the second equation. You have NO on the product side. Here also you have NO on the product side. And the number of NO also is same, 2 NO. That means we don't have to do any changes here. So let it be K2 as it is given in the problem. Okay, K2. Look at equation 3 and look at the equation you need. You can see here, student, this is 3H2O, whereas here it is only H2O. That means the entire equation should be multiplied by 3. That means the equilibrium constant becomes K3 to the power 3. So K for this reaction is K2 into K3 to the power 3 divided by K1. So let us see whether this exactly is the equilibrium constant. First operation I had done was reversing the equation. So let me reverse the equation. 2NH3 giving N2 plus 3H2. So I wrote the equilibrium constant as now 1 by K1. Next equation I have retained as it is without bringing any change. So then the equilibrium constant will be the same, K2. Third equation is multiplied by 3. So you have 3 by 2 O2 giving 3H2. That means the equilibrium constant becomes K3 to the power 3, student. So let us add all these equations. When you add 3H2 gets cancelled, N2 gets cancelled. So you are getting 2NH3 as you can see. 1 O2 plus 3 by 2 O2, that is 5 O2 giving 2 NO plus 3H2. That means we need to add all these things, then you get this equilibrium reaction. So K is equal to K2 into K3 to the power 3 divided by K1. Answer is option A. Option A will be the right answer. So we'll go to the next question. Concentration of the Ag plus ion in a same solution of Ag2C2O4 is 2.2 into 10 to the power of minus 4 mole per liter. So concentration of Ag plus ion in same solution of Ag2C2O4 is this much. So in this problem, student, concentration of Ag plus ion is given as you can see. Solubility product Ag2C2O4 is. So if you can see here, Ag2C2O4 is A2B type of salt. It's a A2B type of salt. Actually, you should know the Sp and Sp for all these kind of salt, student. Like directly you should know. If you know directly, you know that it is 4S cube. Otherwise, you need to write Ag2C2O4 ionizes and give 2Ag plus C2O4 2 minus. Now, let us consider the solubility as S. For this it is 2S and for C2O4 2 minus it is S. Okay, this is 1 mole, so S for 2 mole 2S. We know Ksp is equal to Ag plus raised to the power 2 and C2O4 2 minus. Okay. C2O4 2 minus. So C2O4 2 minus. So you have 2S square and S. So Ksp is equal to 4S cube. Now this relation is valid for A2B type of salt or AB2 type of salt. So students never, try to find out all these relation for usual salt, type of salt, and directly write the relation. Now KSP is asked, the solubility product is asked. KSP. That means you need to know solubility. Now what is the solubility, student? It is given here as Ag plus concentration as this much. We know Ag plus is nothing but 2S. And the concentration of Ag plus is given in the problem as 2.2 into 10 to the power of minus 4 mole per liter. That means solubility S is equal to 1.1 into 10 to the power of minus 4 mole per liter. So now since we know what is S, we will substitute it 4 into 1.1 into 10 to the power of minus 4, okay, 3 times. So this will be, student, 4 into 1.1 into 1.1 and 1.1. So you know it can be how much? 1.331. 10 to the power of minus 4 into 3, that will be 10 to the power of 12. So 4 3s are 12, 12, 4 3s are 12, 13, 4 1s are 4, 5. 5.3 into 10 to the power of minus. So KSP is equal to 5.3 into 10 to the power of minus 12. That is option C. So option C will be the right answer, student. Okay, I hope it is clear. We'll go to question number 6. 20-liter container at 400 Kelvin contains carbon dioxide at a pressure of 0.4 atmosphere. So you have a volume of the container as 20 liter and the pressure of the container as 0.4 atmosphere pressure. And an excess of SRO. Okay, other than this, there is also excess of SRO. Solid SRO, therefore volume we are neglecting, student. The volume of the container is now decreased by the movable piston fitted in a container. So you are going to decrease the volume by moving the piston, right? The maximum volume of the container when the pressure of CO2 attains its maximum value will be. Now you can see, given that SrCO3, strontium carbonate, decomposes and gives strontium oxide and carbon dioxide. That is, for this Kp is equal to 1.6 atmosphere. Students, we all know Kp is equal to partial pressure of SRO, correct, into partial pressure of carbon dioxide divided by partial pressure of SrCO3. We are going to neglect these two because both of them are solid. So whatever Kp, that is 1.6 atmosphere, what is given there is the partial pressure of carbon dioxide alone. So we got the maximum pressure now, that is 1.6 atmosphere. We want to find out the volume. We know P1 V1 is equal to P2 V2 because PV is constant here, isn't it? During the process, the pressure and the volume is constant. PV is a constant. Therefore, I can take 0.4 here, 0.4, volume as 20 there. It's given volume as 20 liter, you can see. Okay. Now what happens? 0.4 into 20. Pressure is 1.6. You have to find out V2. You have to calculate V2. So V2 is equal to 0.4 into 20 by 1.6. So how much you are going to get? You will be getting 5 liter. Right? 4 fours are and 4 fives are. So 5 liter will be the answer. Answer will be student option D. Option D will be the right answer. Okay. The percentage of pyridine that forms pyridinium ion in a 0.1 molar aqueous pyridine solution. So you have to find out the percentage of pyridine that forms pyridinium ion in a 0.1 molar aqueous pyridine solution. Kb value is also given. Now we know that the degree of dissociation alpha is equal to square root of Kb by C. So this will be, students, square root of Kb, that is 1.7 into 10 to the power of minus 9. And the C is concentration, that is 0.1. So it will be almost how much? 1.3 into 10 to the power of minus 8. No, minus 4. If I am removing 1.3 into 10 to the power of minus 4. This is a degree of dissociation for 1 mole. But they want the percentage. Therefore, percentage of pyridine is 1.3 into 10 to the power of minus 4 into 100. So how much it will be, student? So this will be 0.013%. So your answer will be, student, how much? Option B. Option B will be the right answer. Okay. So thank you, students. I will be stopping my session here itself for today's class. So we will see you soon in the next session. Meanwhile, students, see to it that if you are liking my session, kindly press the like button and also press the bell icon for further notification. Do not forget to like, share and subscribe. Subscribe the YouTube channel also, and you kindly watch all my special classes that comes under Unacademy. So thank you, students, and thank you very much.